Hello, everyone, and welcome to today's SANS webcast, ICS Proactive Defense, Leveraging Operational Threat Hunting for Resilience, Part 3. My name is Lauren Ashe of SANS, and I will be moderating today's webcast. Today's featured speaker is Dean Parsons, SANS Certified Instructor. If during the webcast you have any questions for our presenter, please enter them into the Q&A window at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Dean.
All right, Lauren, thank you very much for that. Let's get started, everybody. This is the third piece of this series on threat hunting inside control system environments. If you haven't been here before, a quick rundown on a little bit more about me. I teach the certified, as a certified instructor, I teach the ICS 515 and the new ICS 418 as well. Have roughly about 20 years experience in IT and converged IT ICS environment. My background has really been on telecommunications, but also power generation, distribution, and transmission, oil and gas facilities, and assessments across these sectors and others as well. So joining us for today, we are going to go through the third piece of this series. We've already covered what threat intelligence and threat hunting benefits are, when to start threat hunting inside the ICS, and also we touched on some of those data sources as well, building out a threat hunt package to prepare for execution of threat hunting, which is what we're going to talk about today. So everything from the last two sections will build upon, such as identifying key data sources, using that in actual threat hunts on screen with data. So we'll take a look at this as part 3. So we'll talk about some specifically 3 hypothesis-driven hunts that we've gathered using threat intelligence in the sectors. Also, we'll give you those examples of threat hunt packages specifically for these hunts we've outlined, and also talk about the key data sources. At the end of this section, we're going to talk about all of the takeaways from ICS threat intelligence and hunting in this space. Now, before we get started, of course, we know this is a proactive process, so it's no surprise starting off with active cyber defense. Being that active cyber position in the sliding scale is really where we have to be to get the most value out of these efforts, which are driven by human defenders, driven by cyber threat intelligence, of course, attack hypothesis based on what we've seen the adversary do prior to in other attacks. So what we're going to do is recap the last section, which is part number 2, where we talked about in getting the threat intelligence from your sector, ideally from your sector. Whatever it is, it should have engineering asset information, things aligned to Purdue, OT networks, and so on. That template we also build in part number 2, leveraging that threat hunt package template to specifically lay out the scope, how long it's going to be for an actual hunt, also the assets we're going to hunt around, also the teams identified, and of course, the key data sources we're going to look through for hunting in the environment. Now, it goes without saying, we're going to be starting off hunting around those top 4 to 5 ICS specific assets we've discussed many times here. So I won't linger on it too much, but they are on screen now. The data historian, the human machine interface, engineering workstation, and of course the PLC or other electronic devices in the lower levels of the Purdue. And as we're talking about the Purdue, it is aligned roughly to where you see these assets in the network. So we're going to jump right into hypothesis number 1. So this is threat hunt hypothesis number 1, where we are suggesting, again, based on threat intelligence, we have a Windows OT asset, specifically the data historian, may have been compromised. And in this case, the hypothesis is going to assume that the adversary has compromised the data historian, now pivoting from an IT system into the control system environment. To set the stage for this hypothesis, we are in the electric sector, specifically at the electric power transmission substation. Now, in a transmission substation, you're likely to find a lot of different elements like you see on screen. Obviously, things like circuit breakers with high voltage distributing down to lower voltage in residential areas. We also have, of course, in engineering equipment such as high voltage transformers. And of course, the substation facility kind of generally, in this case, kind of looks like that, an industrial site. for the transmission aspect of the electric facility. Now, I want to point out here, we're going to be monitoring any facility is going to be monitoring a lot of different engineering aspects in the environment. So without even talking about security first, we're talking about different things engineering-wise we're monitoring, such as the load of the electrical system, monitoring and measuring the voltage changes throughout the system as well as it's passing energy to one part of the grid and the other. Of course, these things are also important to look at from a threat hunt perspective or incident response perspective as well. You see, this is not security data, but finding things like spikes and valleys in the data can pivot us off to look at certain parts of the assets in the environment. And also it gives us a time frame of what may have happened around a certain time. So again, the data historian logs are going to come into play as we pivot through this first hypothesis for threat hunting. Now, this should look familiar from the last session that we had. This is that threat hunt template that we'll build out for any threat hunt that we'll have. So you can take this and use this as you build up your hunting experience and your initiatives. Now, of course, in this case here, we have that data historian that's compromised, but the purpose of this hunt is to discover possible logging gaps in the transmission substation in our city of Sand City. Of course, in here, our hypothesis is exactly as we discussed before. Adversary is targeting the data historian, maybe using it to pivot from IT, which we've seen several times in the past, into the industrial control environment. Now, the reason we have this hypothesis is the data historian can share connections from IT and the industrial control in what's called an ICS DMZ. We've seen adversaries do this several times. So the scope for us will at this site be our class A site, we'll call it, or our primary site. It can be a generation facility, but also our main region facility for the transmission area. In this case, maybe we have 230 kV transmission substations, which is fairly large. So with regards to the scope, we know now physically where we're going to conduct the actual hunt. Now, of course, we have to determine what kind of data sources we're going to glean from these environments. Now, of course, we have to meet with different teams on site as well. So the data sources as well, we're going to focus on the Windows OT operating system security logs. No surprise there. Similarly in IT, of course, as well. But beyond that, we are going to look at what I just showed you on screen, which is the OT historian trend logs, looking for those spikes and valleys in the data to kind of warn us about what changes might have taken place in the system overall. So again, not security data, super important for hunting on a control system. Also, the data historian application logs is going to be helpful. For example, someone logging into the historian, making changes, and so on and so forth. And I cannot say this next one enough, the network logs of data going to and from the data historian. And this one will reappear in the next two hypotheses as well. Now, the primary assets, obviously historian, but also the network around that. And our purpose for this specific hypothesis is to scope the environment. Perhaps we have threat intelligence that says we have seen adversaries pivot from IT to ICS before. Here are some known C2 activity IP addresses you could scope for, which we have seen in real life, of course, as well. And we're going to start this hypothesis and this threat hunt by scoping the environment. Now, the actions here really might mean you're going to site with your security team and also interfacing with many different folks on site. As an example, at the very last part of this template, we have the sites and the teams. Before you get to teams, of course, we know to have our safety certifications in place. You also might be interacting with and meeting safety folks on site to guide you through, such as a transmission station or other facilities. The engineering staff on site can also be very, very helpful, as they can probably pull logs for you if you don't typically have access in your security team. Beyond that, because we're talking about a critical asset that's shared between IT and the ICS, the IT security team is also probably going to be present at site, or at least available for questions and also getting data to analyze as well. Now, let's take this threat hunt package and pivot into what we're actually going to be looking for. We talked about those C2s and so on. There's a few other things I want to mention as well. So again, this is a shared device from both networks on the enterprise and control networks. So anything going to and from there from the network perspective is going to be extremely important to capture, to do analysis on. Beyond this, we do see from threat intelligence, such as MITRE ATT&CK, which we'll get into in a few moments, we do see the adversary pivoting in, possibly leveraging cache credentials from an IT network, from an Active Directory infrastructure into the ICS or OT Active Directory. So the things you're going to be monitoring for here are failed login attempts towards the data historian from IT. Also, the successful login attempts can also be very helpful. With cache credentials as an example, it's no longer brute force. The adversary has access already. Unusual authentications as well, the time of day, the behavior of access into the data historian is definitely going to be of concern. Now, this is where we're not specifically focusing on the exact technical data. We're focusing more on behaviors in the network. So knowing the baseline of who is logging into your data historian, where the connections are coming from is going to be pivotal before entering this type of hypothesis. Now, of course, I do want to mention IT and ICS having different Active Directories is definitely the best practice, which also means we have no trust force between those as well. On the data historian, when you're there looking at the OT Windows event logs, one thing I do want to suggest as well is understanding if you have visibility, right? Whole idea here is looking for maybe gaps in logging capability, access to PowerShell being run in the environment. If PowerShell is used on a historian, do we know in your logging system or your SIEM who's been running PowerShell and also what's been passed into PowerShell as an argument to run? We do see a lot of scripting living off the land by the adversary on this device, so we definitely want to look for that. Beyond looking for the access control for the data historian, engineering software also look for things like exfiltration of data. Adversaries have been known to get on the historian and open up a C2 connection to exfiltrate information from the network. And that information can be your data historian trend logs. I know we're in a transmission facility at this particular point, but if we were in a pharmaceutical environment, the data historian probably has the recipe for the medical products you're developing. So exfiltrating that data off can be intellectual property and helpful from another organization from an adversarial perspective. So looking for exfiltration on the network, definitely a good thing. Beyond that, of course, is now we're starting to use more of the threat intelligence from a tactical perspective, knowing any C2s that we have that may be malicious in intent, and also targeting our sector is where we could use this. Now we'll talk about snort rules in a few moments, but generally this is the approach we're taking for this hypothesis, focusing on the data historian. We're going to build on top of this as well. Now this is a completely different hypothesis, but they can link together as we're following an adversary through the kill chain from IT into ICS, from a stage 1 attack to a possible stage 2 attack. Now here we're hunting specifically on the human machine interfaces, the Windows OT device, which can be a traditional operating system, but for OT purposes. And here we're assuming the hypothesis is the adversary is attempting to get remote access to the HMI. Yeah, I know, right? We've seen this many, many times, and Oldsmar will come up. And of course, with 2015 Ukraine attack, and generally this hypothesis is an extremely important one to run because it is more living off the land. It is harder to detect the adversary using system access and system software against itself. So this is the reason we've chosen this hunt specifically in this hypothesis. Now we've moved away from the electric facility. We're going to now focus on a water treatment facility. And in this case here, we're looking for access, unauthorized access to the human machine interface. Now, again, just to represent where we are, this is a wastewater management treatment facility. And inside this facility, there's many different industrial control processes, engineering processes that have to work for the process to actually complete. So there's different devices as well. There's an intake well, there's physical trash racks, there's pumping systems. There's obviously as well things like the filter bed washing systems, which combine software and infrastructure to run that process literally into a field of different sediment and whatnot. There's also flow meters and valves. But at the end of this process, there is a treatment, a chemical treatment phase. Now, this is where we can have a human machine interface operating part of the process, and specifically that chemical treatment phase. In this case here, we're in a water utility, so there are chemicals such as sodium hydroxide, aka lye, in the water. Now, if this is starting to sound familiar, yes, we are modeling after the Oldsmar event we seen in 2021, where an adversary did exactly this, got access to the human-machine interface and changed part of the chemical process. In this case here, changing lye. So we're going to walk through what we're going to look for to see this kind of activity. No, this is not specific to a water facility. Going through what we're going to talk about, the data sources, the different IDs to look for the set point changes is applicable to other sectors as well, if you have an HMI, of course. So let's take the idea of the water treatment facility and move forward with our threat hunt template. So in this case here, we have unauthorized access to the HMI. At this point now, the adversary can control many parts of that process, including the chemical phase as well. So the purpose here is to see if it's possible to hijack that HMI. What access is required for someone to get on the HMI? Is it directly from the internet? Can they pivot internally from the network? Can they also pivot from the data historian we talked about in the previous hypothesis? In this particular case here, we're going to focus on scoping the specific Class A or primary water treatment facility, specifically the HMI that controls that chemical process, because there could be multiple HMIs for different parts of the process. Now, the data sources here are somewhat similar to before, but we've gone beyond the data historian at this point. But of course, we still have to rely on Windows OT HMI logs, so operating system logs. So your typical Windows security event logs and so on is definitely going to be part of the picture here. Beyond that, of course, can't say it enough, the network traffic going to and from the HMI, critical. Now, specifically here, we're going to really focus in on the remote access, which is usually RDP. That can be replaced with TeamViewer and any other type of remote access as well. In this case, we are going to use RDP as an example as we pivot through some of the logs. Now, the assets is obviously the HMI here and the control traffic on the network. Now, specifically here, we're going deeper in the control system to do our hunting. In the other hypothesis, number one, for data historians, we were on the higher level of the Purdue, typically in level 3 or 3.5, the ICS DMZ, and so on and so forth. Now we're getting into control system traffic at the lower levels, maybe in level 2 or 3 in the ICS network. Again, what we're going to do is focus on IOC scoping, but also behaviors as well, unusual specific remote access to the HMI, and specifically on expected set point changes on the engineering applications. This is specifically something we don't always see in threat hunts. It's mostly just on operating system logs, but here we definitely want to go the extra step to get the engineering application logs to see what changed on the process, and that's going to be stored not in the OS logs. Now, our action here is similar, getting on site to the facility, obtaining physical access, and also log retrieval for scoping assistance. Now, in this case here, again, because we are getting network data, we may need additional team and access to pull that. So things like not just your operators on site to operate the HMI, to pull logs from the application and the Windows device, but also from the network perspective. So you may or may not need a network architect here to help pull the PCAPs from the network. Now, with our template all set up and ready to go, we're looking now at an HMI specifically, and here's again modeled after that manipulation on the HMI in the Oldsmar attack, the water facility. The engineering application logs, check. We know that's extremely important. So getting that, which is usually a proprietary part of the drive that's there, we're going to focus on getting that beyond the OS logs as well. Now here we are using the example of lye being changed or sodium hydroxide. You see it here circled in red where there's a pump controlling, or a pump that's controlling the amount of sodium hydroxide that can be injected into the chemical process. So obviously if that changes or anything else changes, like the chlorine that's there and so on and so forth, the fluoride pumps as well, any one of these can represent possible damage to the control environment or the process, and also in this case, damage to people. In this case here, we're talking about a water treatment facility. So if there is too much hydroxide in the water, as we've seen with Oldsmar, it can make people very, very ill, and also death is also possible. So again, looking at those applications logs is going to be extremely important, specifically if there's set point changes, also when the pump may have been turned on or accessed, et cetera, et cetera. Now, here is where I want to make this a little bit more interesting. This hypothesis mostly focuses on the HMI, obviously, But here's where we can see an adversary using the vector of the data historian to pivot to the HMI for control manipulation. So here's where we can say, if your hunt can be broader here beyond the HMI, include the data from the data historian. Specifically, if you did see those values or spikes in the trending data from the historian, now you have a time frame. There may be changes here on the HMI in the application logs as well that correlate specific to the event on the historian. So you see now how we're building a threat hunt across multiple different hypotheses which can be linked together. This still could be one attack in an environment that actually triggers different parts of our hunt. Now, focusing on the HMI specifically here, we're hunting, of course, for remote access. So on screen, you do see a number of Windows event IDs. Of course, that's going to be critical to enable your hunting. So making sure these are enabled on the OS is critical. Now, we do get the question a lot about how long does this data should be on that system for? And typically it's at least 30 days, 60 days, 90 days. That's the common kind of time frame. If you do have the ability to get this off the HMI to a central SIEM, for example, great opportunity to get your logs to do that correlation we just talked about a moment ago. So in general, what are we looking for on the HMI? We're looking specifically about the different Windows event IDs such as 4624, also fail logins as well, 4625. You need to monitor for both of those, see what's successful and what's not. All right, so beyond these two different Windows event logs, there are others as well. And I am reminded here to, if you have any questions as we pivot through, please put those in the comments section and the Q&A section, and we'll queue those up and get to those just in a little while. Now, beyond the IDs we just talked about, there are several others. This one specifically for denial of access. Oh, great. There's threat hunting happening on my phone right now. Specifically denied access for remote desktop in the environment. So you're going to be looking for any RDP access on the network, but on the Windows event logs as well, you're focusing for 4825 in this case. And specifically successful log from a network device through RDP to the historian, you're looking for 1149. Again, the same would apply here, not only for RDP access, but for whatever solution you have to get access to the HMI. So clear as mud. Hopefully this is becoming clear because again, we're focusing on HMI, remote access, behavior changes as well as things like set point changes in the application. Now, beyond this, one critical component beyond the data historian, the HMI, is the controllers and the engineering workstation in the environment, which is where this takes us to the next hypothesis. And again, based and modeled on threat intelligence and previously observed threats, we have seen the adversary control the HMI, update software, and update logic in the controller from the engineering workstation. So let's walk through this hypothesis, focusing on unauthorized project file changes from the engineering workstation, which ultimately leaves us with remote PLC code manipulation. This is the lowest level in the control environment that you can manipulate essentially, and changing like the real aspects of the control environment at the lowest level. So let's walk through this threat hunt template here. Again, we have unauthorized project file access. We do have an engineering workstation that is targeted. We've seen in the past where we have an ability to update the controller logic, or otherwise known as project files. So in this case here, the purpose is to understand if we can get access to look for hunting or look for adversaries in the lower level of the Purdue. Changes to the controllers, any remote terminal units in the field, as well as other IEDs in the field. Can we access that today? What about the logs on the controllers? Are they only local logs, or can you get those logs sent out via syslog to a central controller for OT management? The scope here is, again, a primary control environment, which is IP connected, heavily relying on the PLCs, of course, typically upgraded facilities or modern facilities. Now, beyond what we've seen in the past for our data sources, obviously the engineering workstation, which is commonly a Windows OT device, but beyond that, we definitely have to consider the logs in the controller. A lot of times when doing assessments, we do see that the controller has logging enabled, but it's only to the local device. And sometimes they're not enabled at all. So it's really difficult to hunt at that lower level. So something to keep in mind as we go through. Focusing on the assets, of course, we have those laid out as the PLC and also the engineering workstation. Now, the scope again here is also not just looking at the behaviors, but also looking for scoping in the environment. Any remote access to the engineering workstation is critical, even USB usage on the engineering workstation as well, which we'll get to in a moment. Also, project file access. I want to walk you through an example of a plant that has a Rockwell setup. That could be many different types of vendors in the environment. So the project files and access to those is going to be critical. One of the questions I'll raise here is, where do you store your project files in your environment? Is it on IT network? Is it on the ICS? And do you have control to hunt through data of who's been accessing those files, specifically when they've been updated last? And definitely last but not least, of course, is network traffic as well. And that's where that snort rule comes in just a few moments. Again, the actions here are getting on site with your engineering staff, your network architect in this particular case, for the OT environment, safety staff as well, because you are getting to site, and likely just your ICS security team in this case. So with regards to some of these data sources, we do see a lot of the times, as I mentioned, these are set up, and sometimes you have to go in and configure the logging capability. It may not be on by default. So this is directly from one of the manuals for the PLC for this specific vendor. It literally is, you can change this aspect while setting up the controller, or even after the fact as well. And I do want to point out again, that some of these devices, even though they may be a legacy in your environment, may have the ability to upgrade the firmware to enable the ability for syslog to an OT SIEM or some other aspect for logging and correlation. Going right back to the first hypothesis we've seen, for only focusing on the PLCs here and also just the engineering workstation, do we have any correlation between that, the HMI changes, or any pivoting from the historian? All of this is a really true picture of a stage 2 attack in the control environment. So once we have our logging enabled in the environment, then we can actually pivot to which specific events we're going to gravitate towards first. Now, there's several of them, and there's two we really want to get out of the gate first and foremost. And these are any project file downloads into the environment and any, of course, online edits. So even if the controller is in run mode, you can still edit in some cases. So any of those changes should also be logged in the system locally. And again, where possible, getting those off the system to syslog some other place would be ideal state. We're going to be monitoring as well for things like the status of the controller. The controller can be in different modes, such as run, which means this is the PLC running the code as usual, as expected. Beyond that, if it's in remote mode, this is where things may get interesting. You can have the ability in this mode to program it remotely, and this is quite common. However, it does obviously set yourself up for potential vector for changing the environment as well. As we can change and reprogram the controller remotely, so can the adversary. So the best practice, of course, here is to make sure it's in run mode unless you have to program remotely. Sometimes these changes do not occur on a regular basis, and not often. So having it in run mode is the safest bet. When you know there's a change, getting on site or having someone flip to remote mode can be that protection you might need from remote adversaries accessing the PLC. Now, the other mode, of course, is program, where you're actually programming the controller, and the controller might be stopped at that point. So nothing is running in the controller at this point. Suffice it to say, again, we see entry descriptions here. We see time frame, the user logged into the device, and also the engineering workstation that may have been used to cause that change. Beyond this, and this is proprietary and specific to different vendor software, is the, in this case here, the user ID, FT user ID. This is, of course, is a factory talk ID from Rockwell Automation, but the same would apply to other vendors as well. In addition, there's information about the project file and so on and so forth. Now, this is the information we came to get. If we don't have that, let's mark that down, go back to see if we are logging this kind of events in your specific ICS. But let's not stop there. There's one other trick we can use when hunting in the ICS to at least to see if something changed in the controller. And we don't have the ability to get the specific logs on screen here. At the very least, we can use this trick. A lot of software has this built in, but if you don't, it's very, very simple to understand if the project file has changed. This will not tell you where the project file may have changed or any code changes, but it will tell you if it did change. And of course, if you do have a change, then you can understand if it was a valid approved change through the ICS change board and so on. So what we're doing here is we're literally taking the hash of the project file that's in the controller, so downloading that to your system, your analysis system or threat hunting system, and literally getting an MD5 or a SHA hash of that file specifically that's been uploaded. That contains the code in the PLC. Beyond that, you're going to compare that hash with one you have from a backup that was most recently pushed into production. Compare those. If they're different, obviously something changed. So again, getting additional information about what may have changed might be your next step. And at this particular point, if you are only left with this hash, which are different, you may have to get your engineering folks more involved. There may be manipulation inside the PLC code, and that requires obviously reading the project file and so on. So again, engineering folks will be needed likely for this particular phase. Now, if we move a little bit away from the PLC, but still in scope for our hunt, we're going to focus on the engineering workstation, which is used primarily to program the PLC across the network. As we move into the engineering workstation, there's several things we need to hunt for. We need to understand if there was any USBs used in the device. And of course, if they were, then we can get information from the OS about when it was inserted, of course, but also things like who was last logged in when that USB was connected to the device. And the reason we're focusing on the USBs is for two reasons. One, there is a way to exfiltrate data off the data historian, of course, and sometimes that does happen legitimately with internal processes, but there's also a way to copy files to the to the engineering workstation using USB. And that's, again, legitimate as well. But we need to make sure that they're authorized. We need to make sure we're expecting these conditions and connections. So on screen here, specifically in the Windows registry for these OT devices, you can look up to see what details about the USB there are. For example, if you look to system, you look as well for current control set, you can find out exactly what type of vendor information was part of the device that was plugged in. Beyond that, you can see those users that were using the device at that time, which again here is in another registry key, which is now 0.2 in this particular case. But beyond looking for USB connections in the engineering workstation, it's critical to look at the network as well. Access control goes without saying, but also any exfiltration of data across to a C2. Before we go there, I do want to bring up again, wherever your project files are, they are targeted. We have seen the adversary target these in a number of different occasions. So in this case here, again, using the example of Rockwell controllers, these are common project files and different type of configuration files for this environment. So learn to see what you're using in your environment, look for the related project files and configurations for your PLCs, and understand who can access those. More importantly, understand when they were changed last as you're executing your hunt. Now, if we go a little bit further here from a network perspective, which again, it's super critical to have the network visibility around these critical assets, is you're going to focus on things like unexpected or unauthorized access to the controller, but also to the engineering workstation. Now, a very, very simple rule we have on screen, which is just a basic snort rule or Saracata rule, is you want to get alerted anytime there's something that's not your engineering workstation trying to access your main PLCs in your plant on the programming ports. This will change based on the vendors that you have in your environment and the equipment that you have. But if we follow through this rule, we see alert for anything that's TCP on the network that is not. So this would be your IP address for your engineering workstation. So something that's not the engineering workstation going to a PLC device. Of course, you can set this up with a number of different IP addresses for your devices. And of course, that's on a programmable port. So typically you'd see that being used for remote programming in the environment where the PLC is in remote mode. In this case here, we do see detection for a non-engineering asset trying to attempt to program or access a PLC. This would be odd behavior. So even something as simple as this, hunting through your environment can be helpful. And the next question is, how do you set this up to hunt? And the thing is, if you have a PCAP from the environment, you can use simple tools built into Kali, but also Kali Linux, but also Security Onion, such as TCP replay. Taking that packet capture using TCP replay and having Snort set up, you can take the packets and slam it against TCP replay and the interface in that device with this rule in Snort to trigger if you'd see this kind of activity in the network flow. Beyond this, of course, is looking for C2s. Now you can change this context of this basic rule here, pseudocode, but anything that's going to an outbound connection from your engineering workstation is potentially suspect. So anything that's not an internal 10 address and not an internal 172 address and not an internal 192 address on any port is suspicious, and hunting around these kind of connections anywhere in your ICS is a good practice. So I'm looking at some of the Q&As coming in. Keep those coming in as we pivot through, because now we're kind of winding down to some of the best practices with leveraging some of the frameworks we have freely available out there for us to create different hunts, but also to leverage and understand what type of data sources are out there for different assets. We've only covered 3 here, but I do want to suggest that you can create your own as well. Again, the ones we focused on are threat intelligence driven based on what we've seen. So is the MITRE ATT&CK ICS version. So if you want to create your own hypothesis based on gaps you might have seen with regards to maybe gap assessments you have already completed in your environment, and then creating a hypothesis from that, great idea. You can model it based on the MITRE ATT&CK ICS by going to this website, which is the GitHub version of the Attack Navigator. Once you get here, of course, you have many options to create a layer, or you can continue working from a previously defined layer you might have saved in a JSON file on your system. Once you have that, you can create a new one or load the one you have. And of course, you can select where you want to use it. You can use it in the enterprise version, which is the one we've mostly seen in the last number of years for IT. There's a mobile version, but of course, we're focusing on the industrial control section, which is the ICS area. Loading it up in the ICS MITRE ATT&CK framework, then you're presented with something like this. Now, what I've done here is I've mapped out most of the adversaries for the industrial control system targeting sector we've seen in the last number of years. Colored all of them red. However, some of these are more used and observed than others. So what I've done is I suggest starting with some of these. And what we've done here in the next couple slides is focus on 3 of them, which are some of the top 10 that we have seen being commonly abused. So let's take a look. This is really hard to see because it's kind of tiny. So I've made it a little bigger here, focusing on the actual techniques and the tactics, highlighting again the ones from the ICS area. And then we're going to focus on some of them, specifically 3 that we've seen across many attacks. Now, these are specifically designed and kind of pivoting from our hypothesis we've had earlier. In this case here, we're focusing on T0823. This is the graphic user interface. This is really where we see adversaries, no surprise, SCADA hijack. Adversaries making attempt to gain access to the machine using a GUI, again, that HMI hijack in the environment. Beyond this, more living off the land with T0853. This is the scripting aspect where adversaries have been using scripting languages. Also, Python is one of them. There's several others, obviously PowerShell, even seen in IT, of course, as well, using that to create code on the environment, execute code in the environment as well, or run some kind of script that they would create. So beyond scripting and beyond the graphical user interface, of course, is T0855. This is unauthorized messages in the environment, unauthorized command messages. This is where the adversary can inject unauthorized system commands into the network to control aspects of the system. You've probably heard before, a lot of industrial control system protocols may not have security built in, and this is how an adversary can take advantage of that. So be careful about that. Again, the other thing here is network access. I love picking on this one because if you have network access, you're well ahead when you do your threat hunting, not just only focusing on the endpoint data, which you may or may not have in legacy environments. So network is really important. So if we take these T0823, 853, and also 855 and break them out a little bit more, let's kind of align these to the related data sources we want to get. Let's see some similarities between these 3 and possibly give you a top 3 data sources for your ICS for threat hunting. Now, we've taken the scripting aspect here, the 853. Obviously, the tactic here is execution, some kind of aspect of malware or malicious code in the environment, or just plain and simply living off the land, using it for nefarious purposes. The data sources here are things like command execution logs. So the immediate question comes to mind, are you now looking at PowerShell execution in your environment? Do you even need PowerShell in your environment? And if you don't, then disabling it or restricting it to only those who need it, some of the operators maybe, some of the architects maybe, then you can reduce your threat landscape or your risk surface quite easily. Now, we'll talk in a few minutes about metrics, and one of those metrics will be how you can change the environment proactively rather than find the next APT in your network, which can also happen. Now, the asset for scripting in this case can be on the HMI, but also the engineering workstation. And we have seen that before in the past. When we pivot to the HMI, obviously the human machine interface, we're talking here now about the execution on that environment as well. Remote access logs into the HMI is critical as a data source. Engineering application logs as well. Remember, changing the set points on the HMI is critical to get access to. And of course, definitely not last but not least is the network traffic. Surprise, surprise. Now you're seeing a pattern come up with the data source that we need through most of these threat hunts. In this case here, if we take the example of 855, the unauthorized command messaging, so injecting ICS protocol commands in the network to open breakers at a substation, for example, or change the set points or amount of chemical in a vat for the wastewater management facility, we're going to be looking at these command messages. Again, data sources, no surprise, network logging, but as well the data historian information that can be useful here as well, because your data historian is going to be logging things about the process. This, of course, as well going to be included in your field devices. So you may have logs that may exist only in the field on local devices, your RTUs, and your intelligent electronic devices as well. So with regards to metrics, if you only focus on PowerShell or execution of scripting in your environment, remote access to your historian, and the network data around those critical devices, we're left with you now can track your effectiveness for threat hunting in your environment. Because let's face it, we do have technology to help here, but in the end, we're going to be focusing on us as human defenders to executing a lot of our scripts for this to get the data, to sift through it, and so on and so forth, especially making the context and the connections between threat intelligence and what we should look for. So it's not just a product that'll help you threat hunt. So the metrics you're going to want to look for are not these, which are how many APTs did we find today, right? And you may not find an APT in your first 2 or 3 months at this, but what you'll do is you will hopefully change the environment proactively to make the endpoints, the network visibility better, the endpoint logging better, and also enable authentication where maybe you had none before. So the whole objective here is to make the environment less habitable for the adversary. So metrics you could track are how much restriction you have in place, or what coverage do you have with restrictions for PowerShell in the environment. What now new PLC logging have you enabled in your environment, which are now maybe not just local, but they're network-based as well. What areas of the network have you improved your ICS aware visibility at the lower levels of the Purdue? So getting the control traffic to understand what those commands are going to the RTUs in the field. And another one as well, of course, a metric to follow up on is how many of those changes that were made map specifically to a standard framework like the MITRE ATT&CK for ICS, and some of them are labeled here. So these are generally some of the metrics we'd suggest following rather than finding your next APT in the environment. Now, we're going to close out the next section here in a moment, talking about the main takeaways from this entire series, and that gets to your questions in the Q&A. So I see some questions coming in. Keep that up. Let's pivot now into the takeaways for this series 1, 2, and 3. So the first one I want to mention, of course, is the most effective place to start threat hunting is having established active defense. That means at the very least you have ICS control network visibility. And wherever you can get lower in the Purdue, as we talked about a moment ago, that means your NSM or network security monitoring solution or IDS in a control system environment can look at and understand and interpret and dissect control system specific traffic. Beyond this, of course, that means you have to have the active cyber defense in place, which means you have the technology and you have somebody trained with the engineering background and security background to look at this data. So just as we've seen before, someone getting a PCAP in the environment using TCP replay, that's a great place to start. But if they don't know what they're looking for, then you're not fully there yet. So that's the best place to start. But there are benefits in starting before that, so it's not all lost. Obviously, consuming threat intelligence will drive your hypothesis, as well as some of your internal gap assessments you may have done. But of course, getting intelligence from MITRE ATT&CK and other sources specific to your sector will again make your hunts more specific and more oriented towards the results and metrics you want to track. More specific, the better for your organization. No-cost threat intelligence is available out there, and we have covered that earlier in this series. So I'd suggest starting with those, I think it was like 10 or 11 different no-cost threat intelligence sources, and then shop around later as you mature your program for something specific to ICS and specific to your sector. Now, the kill chain we kind of mentioned before, we're tracking the adversary across the kill chain, which is why I love talking about the hypothesis of pivoting from IT into the ICS. Having visibility of both is going to give you the best representation of a kill chain, but also how the adversary can pivot. Hunt first around the data historian, HMI, engineering workstation, and PLCs. No surprise there. Also, collecting data sources, super important to prioritize those around those critical assets. And of course, making sure your hypothesis is threat hunt driven. So it's basically just mostly about what you've seen the adversary do in the past, because I don't want to get people into the situation where they're only scoping for IOCs. If you are only scoping for IOCs, maybe you'll find remnants of one adversary, but that's one adversary. If you focus on the threat intelligence from a TTP perspective, you're focusing on not kicking out or blocking one adversary, but many. As you change, for example, the use of PowerShell, you're changing the access for many adversaries to live off the land in that environment, as an example. Beyond that, we did cover many benefits from threat hunting perspective, which is obviously getting ahead and doing incident response before the actual incident in the environment, changing the environment proactively. But we did notice along the way in this series that even having the visibility into the control network can also help the engineering staff with troubleshooting they may have in the environment. So there you have it. There are 3 top things we've talked about in this series. The benefits, we talked about where to start in number 1. Number 2 are some of the common data sources and having that template as we build them out. And in this one, we did build out and execute some of those hypotheses, specifically tied back to threat intelligence. Before we get into the Q&A, I do want to suggest that if you ever want to join me in class, I have another teach coming up in June. This one is online and it's also in person. And this is the SANS ICS Europe and the Munich run. The new course, the ICS 515 course, is 70% updated. The new PLC kit you guys keep, and also the additional hands-on labs, 25 plus labs. And of course, day 6 has now been added, which is a full kind of CTF all day. Beyond that, we do have in June as well, the ICS Security Summit coming up. Super excited to get there. Of course, June 1st is the CTF that Sands and Dragos is kicking off, and the summit will take place on the 2nd and 3rd with training to follow. Anybody attending live online, it's free live online. So you have both options available for you. And with that, I'm going to pivot into the Q&A for this session. So hopefully this has been helpful. Let's turn it back over to Lauren to see if there's any questions for us to answer on this one.
All right, awesome. Thanks for that great presentation, Dean. We have some questions ready for the Q&A. However, if anyone has a question for our presenter, please enter it into the questions window now. So our first question is, I've heard folks say you shouldn't use NetFlow on OT networks because it takes up too much memory in Cisco switches and doesn't give you any benefit. I disagree with that, but when collecting network traffic data for analysis, is NetFlow beneficial? If so, in what way?
Yeah, so fantastic question. In fact, when I teach 515, that comes up as a real discussion point. So what I'd suggest is, for sure, NetFlow, if you don't have the ability to get full packet capture, NetFlow is really helpful. So just as we talked about looking at historian data, where we see a big spike in the data in the historian or a big drop or a valley, the same can apply to the network. So as an example, if you're only collecting NetFlow, let's say on the outer edge of your ICS, not even getting control system communication, at the very edge of your ICS, you've got NetFlow data and you're seeing large spikes in the network that could represent remote access, it could represent exfiltration of data, and so on and so forth. So I would say that you're correct. I agree with you, and NetFlow data is very important, especially if you can't get full packet captures. The other side of that is getting full packet captures would be ideal, and I would further suggest that full packet captures at the lower level of Purdue is a really great place to start. But it sounds like you're on your way. That's a fantastic question.
Awesome. So our next question is, in your presentation, you mentioned attacks on water sector. What water sector specific cybersecurity guideline is there?
Yeah, so great question. There's several of them out there, but if you go to waterisac.org, So there's an ISAC for many utilities out there. There's an EISAC for electric, for example. There's a finance ISAC and so on. So if you go to waterisac.org, you'll find a really good place to start. You'll get threat intelligence from that organization as well, which can be free or low cost. So I'd recommend starting there for intelligence, but also guidance for the water sector specifically. Great question.
Okay, another question is, which data source would be a priority first? Windows OT logs or the network traffic first?
Yeah, another great question. And we kind of touched on it a little bit in this session where we talked about, so many times we talked about getting the OT security event logs, getting the OT engineering application logs. But if I could only pick one, I'd love to pick two, but if I could only pick one, it would be the network, because you at least understand what connections are going to and from. And if I had an ideal state, back to the previous question, I could get the full packet captures. I would prioritize the network first, because the adversary usually has to get there across the network. That, of course, does not work well if you have an adversary that kicked in the doors in a substation physically and sat down at an HMI or plugged into the network. But the network is where I would start for sure.
Great. Another question is, what frequency is most common for OT facilities performing threat hunting? Weekly, monthly?
Yeah, so the scope generally, I do see organizations do a scope of about 5 to 6 days. So they'll take 1 week, they'll plan the hunt, use something like the template we see in this session, and then take 5 days to actually get to the site, pull the data, scope it out, run it through a different PCAP analysis tools and so on and so forth, and even get memory captures within a 5-day period. Now, the frequency of that I usually see in mature organizations at least once a month. At the very least, it would be once every quarter. If you're not there yet, that's totally fine. Focus on architecture, passive defense, and active defense, getting the infrastructure in place to get the network traffic, as we talked about, at least the net flow and then the full packet captures. But generally, it's once a month for really mature organizations, or every few months for organizations that are kind of coming up through the ranks.
Great. Our last question is, are there products out there to help map security events to the MITRE attack framework?
Yeah, there are. So, I mean, I can't say it enough that technology alone is not going to save us, but there are endpoint security tools which does map to, oh, we've seen this event. That means the adversary is likely taking advantage of this TTP, and it gives you that T0855 number that you can map back to the MITRE attack. So a lot of organizations, specifically the past couple of years, have been doing that, and more are doing that from an ICS perspective as well. So yeah, great question. And we are seeing, again, more technology being adapting those frameworks. Absolutely.
Okay, well, that was all of our questions for today. Thank you so much, Dean, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast. You can find your CEUs for all completed webcasts by logging into your SANS portal account, navigate to your account dashboard, then click My Webcasts. You can then download your CEU on the right-hand side of the web page. Take care.
See you, everyone.